Okay, so I'm Dom Guinard. I'm indeed co-founder of everything, and I also wrote a book. The book was supposed to be based on my PhD research, but that didn't work too well, so we ended up rewriting it 4 times, not necessarily completely based on the PhD research. My PhD was the Web of Things, basically the Web of Things architecture. You know, it's not a sales pitch, but I realize not many people know everything in this room, and it's actually quite sad because we, whoa, there's a lot of noise. We're actually London-based since 5 years, connecting all kinds of objects for all kinds of brands. We are actually close to connect 1 billion things. 1 billion things, can you imagine that? So we're already at 500 million right now. And the reason we're already at 500 million is we connect all kinds of things. We connect things in the supply chain, like bottles of Coke, but we also connect consumer electronics, like in the smart homes for brands like iHome and etc. And we're always hiring, so if you're a Node.js, Angular, Java, or a product owner, please come and talk to me. We'll be happy to talk about the job. Okay, but the reason I'm here today is basically to talk about the Web of Things and about the book called Building the Web of Things. So what I'm going to do is I'm going to give you an introduction to what the book talks about, right, chapter by chapter. Unfortunately, I can't go in depth because it's a 200 or 300 pages book, but I'm going to try to give you the essence of each chapter to see if there is anything that triggers your attention or anything in this book that could be interesting for you. Basically, the book starts on the principle of the Web of Things. The Web of Things is probably, you can consider it as yet another buzzword. It was coined in 2007 by a couple of researchers, including myself. And it was a reaction, basically, a reaction to the state of the Internet of Things. At that point, I was working for a 3-letter company that I'm not going to mention because this is on video. And it's a German company. And it was, one interesting bit is that we were trying to crank in very complex protocols on sensor nodes to basically expand the business of this company. And we realized that, you know, the state of the Internet of Things wasn't that great, actually. You had lots of different protocols, and if you really wanted to build an Internet of Things, you basically had troubles because most of these protocols were not Internet, right? And that's, for me, is a big failure as an industry, and it's still today a big failure, right? If the Internet of Things we're building is an Internet of Things where you have 10 apps for 10 devices, or even worse, 20 apps for 10 devices, that's not the Internet of Things, right? Consider the smart home. Smart homes have been around since 1975. You know, it exists, right? I mean, X10, BACnet, all these protocols exist already. What the Internet of Things should be about is bringing the Internet element in that picture, right? So it should be about converging these networks to the Internet, and we advocate converging them to the web. So our approach has always been, just like the Internet mushroomed with the web, thanks to the application layer of the Internet, which is the web, there is the same kind of core principles that we should apply to the Internet of Things so that these protocols, and some of them have a good reason to exist, can converge at the application level through web APIs so that you can easily integrate devices together and that you actually can have one app that talks to all the devices. So basically, the idea of writing the book was to report on 10 years of what an IoT from our PhDs to the real world through everything and other companies we work with. I'm saying we because I wrote this with my co-founder, Vlad Trifa. We also wanted to encourage people to build web-connected things. And the web aspect for me is very important, right? It's all about interoperability, openness. And we wanted this book to provide an end-to-end methodology to build IoT products. What we've learned over the years, we wanted to show it there to be able to, you know, teach that at universities or for innovators, for developers, or people who want to get into the IoT. Another aspect was the W3C actually founded an interest group called the Web of Things Interest Group, and we're, of course, founding members of that interest group, and we wanted to report on the early work of the W3C in the Web of Things. Okay, that's it. So the way we actually started writing the book was indeed looking at our PhDs, merging them, and basically pushing that to the publisher, Manning. And they went like, well, you know, that's great, but let's rewrite the whole thing, right? And one thing they told us very early on, which I found really interesting, is if you really want to captivate your audience, you need to show them what they can do by the end of the book, very early on in the book, right? So what we did is this device, which is also here, based on a Pi 0, this one, is actually running at the Everything Office. And if you go on devices.webofthings.io, you can see it running at the Everything Office. You can actually interact with it. You can start programming it from the word go. So in chapter 2, you can directly write code that actually talks to a real-world device. And what's interesting is you start to, anyone who did C programming, you know, interacting with a device like this with embedded frameworks is complex. However, when you put the web aspect in the picture, it becomes really easy. And I guess we're all convinced that, you know, the web actually make it easy to build applications. And well, so many people started using the device when the book was launched, even before the book was launched, from all over the world. And what's interesting is they leave a message when they use the device, and we pick these different messages from pretty much everywhere, from India to Germany to Argentina. And so far, we never had an offending message. So if you want to send one, be my guest. Okay, so chapter 3 goes into the real meat of the program, although I'm vegetarian, so I should probably not talk about real meat. It goes into the core of what you're going to learn. And it goes into the language that we're introducing. We actually wondered for a long while what language should we pick for the book. We were and we still are Java guys, mostly. But we thought there was a language that was quite interesting. And this language, which is a framework, is called Node.js, right? So back in the days, embedded programming looked pretty much like this, right? So C ruled the world. Windows-based IDEs, one IDE per platform, and I've been there, so I know a little bit what I'm talking about. Small community, very highly specialized people, very resource-constrained devices, and integration via special SDKs. I think what Node brought to the picture is very interesting because Node actually brought the hipsters to embedded devices, right? That's not per se necessarily a good thing, but what's really good is it basically democratized the whole space, right? I'm not sure I would run Node on a very resource-constrained device in production. However, what it brought was the ability to prototype very quickly. And you know, Node has a large community, more reach, more innovation, a huge ecosystem of libraries, and it's very well integrated to the internet and the web. And you see devices that actually pop up that support Node very, very well. So that's the Intel Edison, the Arctic platform. We have big Arctic people in the crowd, so if you want to know about the platform. They even want to crank in Node.js into their microcontroller version, so into their very resource-constrained version that will be launched soon, the Arctic one. Okay, chapter 4 goes into electronics and tries to show you how to basically connect a bunch of sensors to the GPIOS of your Pi. That's trying to give you the basics. It's very hard, of course, to cover electronics in one chapter. Also, Vlad and I are not experts. We blew quite a few things when writing this chapter. But it gives you the basics, and it teaches you how to work with GPIOS, and especially the Node libraries that let you actually access the GPIOS. And there are lots of libraries. The one we selected for the book is called OnOff, which is a pretty awesome Node library for simply interacting with GPIOs. And chapter 5 actually goes a little bit more into the academic framework, right? So this is the Web of Things architecture, so that's what my PhD thesis was pretty much about. And the idea of the Web of Things architecture, which is also used as a basis in the W3C group, is basically looking at what can the web provide to the Internet of Things. And I tried to organize a little bit things layer by layer, showing you you can actually go deeper and deeper into integrating things to the web using existing technologies or adapting pretty interesting web technologies. So once you're connected to the internet, the framework goes into what are the different bits and pieces you can borrow from the web to seamlessly integrate objects to the web. Okay, so the chapter 5 is probably one of the most complex, but also one of the most valuable, especially for people who begin with the IoT. It talks about the network, it talks about the internet. How do you bring things on the internet? And it talks about the diversity of networks and why these different networks exist, these different solutions exist. So it takes you from Bluetooth to Zigbee to LoRa, Sigfox, to things like an ocean thread, and to the more IP and web-based protocols, and tries to put them in a galaxy, understanding why those one exist and the other also exist. And it's trying to, withdraw conclusions, helping you to understand when to select what language. And actually to, oversimplify, when to select what protocol, sorry. And actually to oversimplify, I would say it depends on two factors. It depends on the energy you have, right? So how much power do you have? Is your device powered or is your device running on battery? If your device is running on battery, you need to look at a different range of protocols. We heard about LoRa, the Things network this morning. It's great, especially for a device that's actually not battery powered actually. If your device is not battery powered, is plugged onto the mains, then we advocate that the more you go towards IP and web, the easier it is going to be to build your application. The other thing obviously is cost, right? I mean, most completely IP and web enabled devices tend to cost more than super cheap microcontrollers. But this is also changing, right? We see devices like the Raspberry Pi, full Linux device, Raspberry Pi Zero at a $5 price point, and I think this is not the end, right? I think the prices are going to go down. Okay, the layer one is about access. So your device is on the internet. That's great, right? It can talk IP, it can talk either TCP or UDP. But how do you actually build the access to your device? So this is all about the core web protocols. Who here is familiar with the REST architecture? Okay, so I'm not going to talk too much about that. But basically, what the book shows you is how to take these things that already exist on the web and apply them to the physical world. And it's quite interesting because you can see there's a match that almost feels natural, right? You can organize the resources of the real world using a restful architecture quite easily. So the basic principle is that every single thing gets a URL. And by the way, the close to 1 billion everything things have a URL, a unique URL, each thing, right? So that's the basis. Then that URL is actually the root URL of your device. And then you can start modeling the different resources of your device. So you can have actuators, sensors. Sensors, you will usually do a get on a particular sensor to retrieve the data as JSON. An actuator, you will do a post or a put to actually send comments to it. And basically, what this looks like at the end of the day is this. And I take pride in always lighting up an LED every single talk that I give. That's very important, I think, to keep up the good spirit of the IoT. So basically, very hard to read, I guess, for you, but I only have one hand. So this is a post on actions, LED state. I'm going to talk a little bit about actions later on. And I just post JSON to that device, and the LED should light up. And we should all be super happy because we are all IoT people. There you go. It's very hard to see. Thank you very much. Yeah. This is why I love the IoT crowd, because whenever I go to a business event and I turn on an LED, people are like, what the heck is this guy doing? So you are awesome. Okay, chapter 7 goes into, well, we are big web advocates. We love the web, and we would like to see the web on every single device out there. The problem, though, is that it's not always possible, right? So Not all devices can speak HTTP or WebSocket, because we also introduce WebSocket for the real-time aspect. For instance, if you have a PIR sensor, you don't want to ask this PIR sensor over HTTP, what's your state, what's your state, what's your state? So you rather push it as events through WebSockets. And WebSockets are great for that, right? Because applications understand WebSockets just as good as HTTP. So we look at a number of other protocols, right? And what we look in particular at is MQTT and CoAP, because these are two protocols that we actually have experience with in the real world. And we look at the respective stack, we look at the limitations and the goodness of each protocol. Basically, the goodness of CoAP is basically it's HTTP, it's REST, but implemented in CoAP. Basically, we have two real-world implementation of REST. The REST patterns, we have HTTP and CoAP these days. Could argue HTTP 2 is another implementation. And we basically look at, the fact that what's interesting is that in CoAP, you also use resources just like you use resources in REST. And you can very easily map the two protocols. So we teach you how to build a gateway between one protocol and the other. But we also emphasize on the fact that if you don't have to, you should maybe not build a gateway, because the gateway, deploying the gateway in the real world is actually quite cumbersome and quite tricky. So if you want to really apply the real world check on the protocol you choose, you should choose the protocol that actually today will make it the easiest for you to be deployed, right? Because things like 6LoWPAN are absolutely great, right? But by the time all home routers support that, it's going to take a while, right? Usually the turnaround time for a home router is about 10 years, right? So that's not exactly quick. Okay, so we also then look at MQTT. MQTT is a great replacement for WebSockets. It adds a lot to WebSockets, and it can be actually easily proxied to WebSockets, because it's also based on TCP/IP. So we show you how to build that. In chapter 7, we show you the cloud pattern, right? Another way to see it is actually communicating with the cloud using a protocol that's non-IP or non-web, and then using the cloud to translate that into things that applications can understand. We went looking around for different clouds that existed out there. We selected the best one, called Everything, and we actually show you, that's when you're supposed to laugh. So we then show you how to integrate everything and create a smart plug that actually talks MQTT to everything, and then everything serves the data in real time to applications using HTTP and WebSockets. That's also something that's covered there. Okay, then we jump into layer 2. Layer 2 is interesting, right? Things now are on the internet. They're on the web, so their APIs are accessible through REST, WebSocket, etc. Now the question comes, how do you find things? How do you actually find things on the web, just like you find web resources? And the key questions are, how do you find the root URLs of a web thing near me? So how do I find that single URL that lets me access the device? What messages can I send to those web things? It's great to be on the same application protocol. We all use HTTP, WebSocket, JSON, but that doesn't mean anything semantically about the payloads that we're sending. And then what do these resources and messages do? What is really happening when I do a post on a particular device? This is really what the W3C Web of Things group is about, right? So it's about standardizing this, but we're trying to standardize it at a very, very lightweight level, right? Without going into crazy heavy ontologies, using things that are simple enough to be actually used in practice. And you can find the first submission is called the WebThing model. That's the first submission from this interest group. There will be many more. The WebThing model is not a standard yet. It's a proposal. But it already shows you the trend, the kind of resources that are being built to standardize interaction with web devices. Okay, layer 3 is all about sharing, right? All of this doesn't really make sense if all you want to do is interact with the light at home yourself, right? It starts to make sense if you want to share it, if you want to pipe different data from one system to the other. If you do that, clearly you start to have to think about things like security, big times. But you can also open your mind and think about very creative ways of dealing with sharing objects. So it looks at the security aspect. So how am I sure that actually my data is not intercepted? How am I sure that the device can authenticate the client? That's usually using API keys or certificates. And how can I ensure that I'm talking to the device? That's using things like TLS or DTLS for resource-constrained devices. And then it goes into a bit more of a crazy story. That's an application we wrote back in probably 2006 that was called Friends and Things, also known as FAT. And it was all about the social web of things. Provided we secure things, and provided these things are actually described using a semantic language, we can start to imagine applications that actually can understand the thing you want to share, understand your social connections, and let you share with real people, right? So here I'm basically detecting, based on the RESTful API that I created, I basically detect the kind of devices I have at home, and I can start to share them on social networks. I can share them with groups like family or friends on social networks. The first time I used that, I shared my temperature sensor to my sister, who was not really understanding what I was doing, but basically by clicking a link on Facebook, she could then see in an authenticated manner, secure manner, the streams from the temperature sensors I have at home. Last layer is Compose, and Compose is all about mashups, right? It's all about how can you actually leverage the goodness of all of that to create applications even without coding. And we have some pretty big people in that field in the room, tools like Node.js. We also have one that is a little bit older and much less cooler than Node.js, but you can also try it. It's called What a Mashup. That one is purely on the client side. And you have also things like IFT. So basically that lets you create workflows that actually help you to pipe the different data, thanks to the fact that everything is on the web, pipe the different data and create cool applications. And I don't know how many of you know the maker channel of IFT. Do you know that channel? But that's a pretty cool secret channel that if your device talks web, HTTP, basically you can integrate any device into IFT. It doesn't need to be an IFT device. So that's basically what you can use to talk to your what device. Okay, the book, that's how the book is doing. It's being used at several universities and got so far good critics. Of course, I didn't write the bad critics. There were also quite a few, but it's actually ramping up a little bit. And if you are interested in the book, the first 3 people who tweet at @whatbook, I will give them a copy. You can also get it on Manning for 39% off or on Amazon. And if you want to know anything about the book, just let me know afterwards. Thank you very much.